Hello everyone. In this video, we're going to be solving an equation with 2025th degree in honor of the new year. It's not a Happy New Year problem because we already did that, but I still thought we're still in 2025, so why not do this problem? So it was originally a little different. I changed it, but once you get the idea, you'll know what I'm talking about. So first of all, this problem, I don't even know how to name it as a polynomial, but it's a huge dual mill something. Anyways, you get the idea. 2025th power is what we have. So, and then it's followed by x. There's a linear term and quite a few terms are missing, right? So there must be an easy way to do this problem, don't you think? Well, there is. If you pay attention, and I could probably put everything on the same side. As is, it's easier, but I'm gonna show you how to look at this problem in general. So one of the things that you should always check, and I mentioned this when I do my videos, almost always I talk about these things. If you have a polynomial equation, then you should always check the sum of the coefficients. Why? Because if the sum of the coefficients is 0, then x equals 1 is a solution. I also encourage you to check the sum of the even powers and the sum of the odd powers, I mean the coefficients. If they're equal, x equals -1 is a solution. You see? Those are really good shortcuts and very easy to check. For example, here if you look at the coefficients, we have 1, we have 25, and -26. What's their sum? 1 plus 25 plus -26, of course, is 0. Yay! We got a solution, which is x equals 1. Makes sense? You could also see that real quick by looking at the original problem, because look, 1 plus 25 is 26. That should be somewhat obvious, right? If you've done many of these problems, it's going to be easier for you. But basically, x equals 1 is a solution. But the million-dollar question is, what about the other solutions? And I would say, okay, you can do a polynomial division, even though I know that it's going to take forever. Not forever, but probably a couple hours. Who knows? You can try it. So basically, if you are interested in the other factor, you should divide this. By the way, this is how we divide in the United States, and every country is different. I know they do it differently in Turkey. It's the other way around. But here, it's more like we're dividing x minus 1 into something else. Make sense? So like if I'm dividing 2 into 8, 2 goes into 8 4 times, so on and so forth. That's how we divide. Kind of backwards, but sort of anyways. So this is the division problem. First, you're going to get x to the power 2024. Then you're going to distribute x to the 2025 minus x to the 24. And then you're going to negate and add, which means subtraction. They're going to cancel out, and you're going to have to deal with this, so on and so forth. You see, that's very problematic because you're going to have a lot of terms. Wolfram Alpha can probably do it for you, right? You can give it a try, but this is going to take a long time. That's why we're not going to do it. What are we going to do? We're going to prove that there are no other solutions. Wait a minute. How do you know that? Well, I kind of thought about the problem, so I should know, right? But let me tell you, I'll let you know how I knew that this equation will only have a single solution. By the way, if you have a polynomial equation of even degree, you have to have at least 2 real solutions, okay? But, wait, did I say that? No, I'm sorry. If you have an even degrees polynomial equation, all solutions can be non-real. But if you have an odd power or degree polynomial equation, you have to have at least 1 real solution. You know why? Because complex solutions come in conjugate pairs, and when you have an odd power, you'll have a leftover. Make sense? Cool. How do we find that? We can't find the other solutions because they don't exist. But wait a minute, why is that happening? Let me tell you why. We're going to go ahead and put this 26 on the other side and call this f of x. So I'm trying to solve for f of x equals 0. Just remember that. In other words, where does this polynomial intersect the x-axis besides x equals 1? Of course, I know that f of 1 is 0, but are there any other intersection points? If there aren't any, how do you prove that there are no more solutions? Okay. Calculus to the rescue. Yay. We're going to differentiate this function. It's going to give us 2025 x to the power of 2024 plus 25. That does the trick. You know what? This cannot be 0. And do you know why? because this is an even power, that's a positive number, and an even power. Suppose this was 0, right? Suppose this is 0. On the contrary, then from here you're going to get something like this, right? And then x is going to be the 2024th root of negative 25 divided by this number. But wait a minute, you can't root a negative number. An even root doesn't exist, it's not real. So we can also approach it a little differently and say, oh, okay, notice that the derivative is always positive because it can't be 0, it can't be negative. This is non-negative, this is positive. So the f prime is 0, which means f of x is always increasing on the real axis, which means it's only going to intersect the x-axis once, and it's not at 0, by the way. I don't know why I marked it that way, but don't worry, I'm going to show you a graph. Okay, ready? So what am I trying to say? Let me show you the graph and then I'll talk about it. I'm trying to say, and by the way, Wolfram Alpha gave me this graph, which is very, very like straightforward. I don't know why, probably because of the power. Notice that between 0 and 1, graph kind of raises up a little quickly, but notice that in order to fit it on the screen, they had to scale y-axis differently. That's why you kind of see a straight line, but it's not a straight line. It is a curve, but the way it curves is so subtle with the scale. The idea is, though, it just shoots up at 1 because x to the power 2025 is super duper powerful, pun intended. So what it means is x equals 1 is the only solution, and there are no other real solutions. And you don't want to find the complex solutions. Trust me, you don't want to find them because you can't. All right? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. By the way, I forgot to tell you something. Hold on a second. What was I going to say? Oh, yes. So could we solve this problem without using differentiation, right? So here's one thing you can think about. This is an odd power. This is an odd power. If x equals 1 is a solution, can negative 1 also be a solution? And the answer is no, it can't. But can there not be any other solution? I don't think you're going to be able to find it with the f of x. Well, what was I thinking? I kind of lost my train of thought. But anyways, you get the idea. But if you do know of any other way to approach this problem without using derivatives, I would really appreciate it if you, I would really appreciate it if you wrote a comment about this. But x equals 1 is the only solution, basically, as a conclusion. And this really brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.